Hi everyone, my name is Kanak Tahake and my practicum project is Responsible Vulnerability Reporting and Disclosure on Blockchain. So, vulnerability reporting is a practice of reporting security vulnerabilities in softwares and hardwares. And these vulnerabilities needs to be addressed by their respective vendors before any malicious attacker could take advantage of them. Furthermore, these vulnerabilities also need to be disclosed to the public or the customers very promptly. Based on research, what has been found that current reporting platforms have shortcomings, such as they are mostly been managed by private central entities. There is no assurance of fair rewards to the reporters. Minimum incentives are driving the vendors for their vulnerability timely disclosures, and customers are often unaware of the risk and to their asset because of these vulnerabilities. The complete life cycle of vulnerabilities, say from discovering, reporting, patching, and everything, involves multiple parties, and each of them have their own barriers and motivations. There are silos of market solution to address them, but they fail to work together and often needs a third-party involvement. So my take for the solution was by using a blockchain to implement a more transparent, privacy-focused, and incentive-driven system to the traditional vulnerability reporting and disclosure process. So the solution would provide immutability to vulnerability report and we can track any modifications. Reporters and vendors can work together, adding, appending their findings to these reports. And we would provide transparency to the process by making the number of solved and unsolved vulnerabilities available to public. Thus, this provides like a clear incentive and enforced deadline for the vendors to patch their product in time. Also, we can ensure like a responsible disclosure of these vulnerabilities using deterministic smart contracts. And finally, we can maintain privacy of the reporters and ensure the valid rewards would be given to them. So the solution was designed in such a way that we can bring the best of the both worlds, that is from bug bounty and in-house vulnerability reporting programs. So the solution is unique in a way that it would allow vendors to participate in a permission network, and multiple vendors will form a network which will then execute different smart contracts and validate transactions flowing through the network. Again, each vendor will have its own secure and private channel or ledger where most of the vulnerabilities related transaction would be handled. However, we would have the chain code used by each vendor, which would be distributed and managed by the common orderers, thus maintaining the integrity of transaction and having a unified verifiable chain codes. A central ledger will also keep track of all the metadata and metrics across the network, and this ledger is associated with a common channel which is accessible and verifiable by all participating parties. We can see in the diagram shown here. Finally, the architecture of the system looks something like this. In the center, we have API service, which is a node-based service, which would talk with all the different components in the system. Then we have UI, which will provide submit update vulnerability to the users. We have IPFS, which is a distributed peer-to-peer file system for storing reports. Then the API would use Hyperledger Fabric SDK to execute and get uh, chain code relevant data. Uh, and finally, the chain code itself would write and keep immutable records of report transaction and rewards, which is being taking place throughout vulnerability lifecycle. We would also have an option to integrate with third-party services here. Let's quickly move to the demo. This is where we have chain code and all the things which will go in the network. So in contracts, we have different contracts. In models, we have report, payload, rewards, and all this code. Further, we have the API, which talks with every other components and kind of brings everything together. Finally, this is where the complete Hyperledger network would stay. So the deployment scripts, all the required cryptographic files and the Docker templates all reside in Hyperledger Fabric Bitcoin network folder. So quickly, I'll start the deploy chain code thing script, and what this would do is it will kind of jumpstart our whole Hyperledger network. So creating different organization, creating consensus between them, writing the policies for consensus, installing the chain code, all would take place in this. This particular step requires a lot of time, so I'll be fast forwarding this for the demo, but uh, at least we get an idea what is happening. If we see on the left side, we have different containers, and this one by one would start coming up here. As you can see, only when most of the peers in the network approves of the chain code, then only that chain code would be installed on the individual node machine. So any corrupted or any altered chain code, if a particular vendor is trying to install, won't be validated by the other vendors and thus would be discarded. So any malicious act is being avoided by using this. All our deployment is finished. We see we have three order nodes, which is being grouped in a one order bucket. And then we have different organization, and each organization has their different dependent Hyperledger Fabric component. And finally, these are the four chain codes running on this individual organization. Now, let me start the API server. So this would start at a 3000 port. Finally, let me just close all these things at one side so that we can see it side by side, all the queries which are coming through. Also, I'm showing this is the IPFS node which has been running. The basic login page which will be greeted to any user visiting the platform. And to log in, the steps are very simple. You have to choose your user type. This could be either vendor or reporter. So right now I'll be choosing vendor. And then we have option to select our identifier file. So in our case, I'll select from the vendor, we have this Apple vendor ID. Uh, so once we log in, this would be greeted to a dashboard where we can see all our published policy, submitted report against the policy, different product ID. And let me just quickly show our API itself. So we see we are running queries like fetch query, fetch reports. All this is being happening from our API itself. So if I reload this, the new data would be getting by the API. Um, so coming down to this, in the policy, we can see all the priority, the description which was given, again the reward amount against that policy, all these things. And if we select a particular policy, we'll get the required reports which had been submitted for this specific policy. So in this case, we have this report which was validated by the vendor itself earlier, and we can read all these descriptions here. So we also have the reference, CVSS score for that report. And any upcoming disclosure which are in say next 15 days will be highlighted here. And there is also like a cron job running. So as soon as this report's disclosure date hits, then automatically the vulnerability would be put into public state. So what we'll do is we'll create a new policy so that we can go through this life cycle quickly. So we have like iPhone, iCloud, iMac, Apple. So let's create a policy say for Apple TV. So I would say Apple TV, say kernel policy, product is Apple TV, and then some default text. I'll say disclosure period to be 60 days, reward amount to be $150, priority set to 3, and scope is say iCloud.com, or say appletv.com, and allow the text, say let's say default. So once we submit this, uh, the policy is created, and also RSA key would be copied to our clipboard, which I can paste it here, which I can use it in future to kind of decrypt my documents. And again, this will be still stored on the client side if this could be automated, but yeah. So as you can see, a new policy with Apple kernel policy and all these things which we have set easier. And now see we have Apple TV as well, and if we click, there are no such reports as of for this particular thing. I'll quickly log out and we'll log in using a reporter account. And this time I'll use a user ID of reporter, which is Hacker42 in our case. I'll quickly log in, and this will bring me to a reporter's dashboard. So we'll see all our reports here. So all the reports which were submitted by this reporter previously, the rewards which he had gotten so far, and the complete picture would be reflected here. We'll also see any other policies available in the market. So we have most from Apple, another is from another vendor, Microsoft, which is R2 in our case. And all we have to do when creating a new report is like select the policy which we want. So for instance, this one, the one which we just created, I can select a report, say Apple TV device report. I'll put some description, which I've just some dummy description I've created. Once that has been populated, I can put some reference, say this reference ID. I have an option to upload a file. So right now I don't have any file, but just I'll upload my previous project proposal as a file and I'll submit it. As you can see, all these things have been processed here and we have a successful, and this document hash is also, I can copy, can paste the IPFS hash, and this is where we get the encrypted data. Again, the RSA key can be used to kind of decrypt this particular file. Coming back, so if I update my reports here, we have this new report which has been added to this set. Again, the same description is here. So as we see, this policy has like 150 reward, right? Let's keep a close eye on the reward which I had previously. So I'll log out. Let's go back using the vendor's identity. Let's select this report. We have this new report here, and just like go through a quick vulnerability lifecycle. Again, I don't want to put a lot of things like validating all those things. I just say quickly a valid report. Again, this could be like more complex, but for the demo, I've just kept it simple. The status could, I could put it like valid, invalid, duplicate, out of scope. I'll just say valid. And again, issue reward is only that could be issued only when this one is closed. So I'll update this. So report has been updated successfully. We see it is in a valid state. Again, so I can again go back to the reporter and see, but what I'll do is I'll re-update it. I'll say it as a closed. I'll add, say something like we have deployed patch update, and then I get this toggle to kind of issue reward, and this will all everything would happen on chain code itself, and the reward amount would be taken from the policy and will be given back to the reporter itself. So let's say issue reward. We see report updated successfully. Also quickly, if we want as a vendor to see the report, we can click on this button and this will bring us directly to the IPFS hash which was earlier shown. So this makes a few things much easier for us. Coming back, let me quickly log in using reporter, select the reporter ID, and we see that our new reward has been updated successfully. And we see this report has been closed. Again, on the reported side itself, this I forgot to show, but we also have like an update option wherein a reporter can add his own comments, bring it back to this thing, and we can raise a dispute as well. Coming back to our evaluation slide, since we cannot work with real vulnerabilities, the metrics were collected using simulation cases based on different states in the vulnerability lifecycle. So I created like a Python script and think it like as a decision tree wherein we start with the vendor creating a policy, then reporter creating a report against that policy, and in some cases it would be a valid, in some cases it would be invalid, in some cases the rewards would be distributed, and so on. Further, reporters can also dispute and negotiate. So all these things are taken care in the simulation cases. So looking at the graphs, the first graph shows the fabric, which is like the blockchain network setup time. And the first on the left side, we have a setup from a complete ground up, and on the right, we have a onboarding of a new vendor. So as we can see from the ground up, it takes around like 220 seconds for a four org network and something around like 40 seconds for a one organization network. Comparatively, onboarding a new vendor is a very quick job. In the second graph, we have this average request time across like 1,000 plus requests for adding policy, adding report, fetch policy, fetch report, fetch reward, or even updating report or policies. In terms of limitation, our current implementation is based on permission-based blockchain and requires some level of configuration and efforts to onboard a new vendor. So we have to create like a certificate authority, create their certificate, create some identifiers, and then set this all up. So it requires a bit of time. Again, if at all majority of vendors form consensus, can be able to manipulate new vendor onboarding or even some newer transaction coming into the network. This is called as a 51% or a majority attack. Although they cannot alter the data which is there on the ledger, but they can stop a new transaction coming in if they form a majority. Finally, the architecture, the API server is a single point of failure, and as it's talking with everyone and just one instance was running, but this could easily be removed by adding redundancy and applying some scaling solutions on top of that. In terms of future work, we can integrate a NFT minting solution to our platform so that a CB specific unique NFT can be rewarded to a reporter, which he can then showcase publicly or can trade it for money. Also, we can integrate native payment into our platform, such as Bitcoin, Ethereum, to the user wallet amount which was given out. Also, the common ledger can be piped onto a public blockchain for maintaining a public trust. So even if somebody don't trust our network, then at least we can know that the data which was piped out to a public network is secure and is not been altered. And finally, like integration with third-party services like CV programs such as cv.fighter.org or giving out notification to social feeds such as Twitter and Slack, as we can see here below. So that's all from my end. Thank you, everyone. I hope you liked it and looking forward to all of your feedbacks. Thank you.